Alrighty, welcome back boys and girls. It's your main mathematician coming to you live from Alameda International High School. And in this video we're going to be still working with these circles, but now we're going to be saying, alright, given that arc length or the area of that circle or sector, what's going to be that radius or that angle amount of theta? So some review for you. Make sure you can kind of have these definitions down by now, but we're still practicing. So if we say a circumference of a circle, we're talking about this. We're going to say C is going to be equal to the pi times the diameter, or you could say circumference is equal to 2 times pi times the radius. So again, make sure you have those labels for yourself and see how they are similar to those other formulas. However, for area of a circle, if we say area A is going to be equal to pi times the radius to the second power. And make sure you're not multiplying by 2, but you're raising it to that second power. For arc length, we're going to say arc length S. It's going to be similar to this circumference formula, but we're going to say it's going to be part of that circle. So we need that angle amount theta. Again, that's not a zero, that's the Greek letter theta for an angle amount in degrees. So we're saying theta divided by 360, and that's going to talk about that part of the circle, and then we have times 2 times pi times the radius. However, for the area of a sector, similar to the area of a circle, we're going to say, all right, area of that sector is going to be the angle theta over 360, and then we have times pi times that radius to the second power. So you can make sure you're using that exponent button when you have that radius squared. So again, make sure you also saying if you need to mark for yourself, we have r is going to be the radius, and we have d is going to be the diameter. So again, make sure you have those labels down for yourself. So now, some new ideas for today. Make sure you're saying, okay, we're building off some previous ideas and we're applying it to new situations. So in this example, it says find the angle of the sector. So it has some amounts that we have, so make sure you can do your labels first. So what does it give us? Well, it gives us this arc length. So we can say this arc length S is going to be equal to 17.59 centimeters. So we're saying this distance of the entire circle around the outside perimeter is going to be 17.59. And then saying that the radius is going to be 14. So we have the radius r is going to be 14. And what are we looking for? We're looking for that angle amount theta. So now we have to say, all right, what can we use? Well, let's try using that arc length formula at the very top. So we have our arc length. So we're going to say, all right, we're going to say S is going to be equal to, and then we have our angle theta over 360, and then we're saying times 2 times pi times the radius. So that's going to be our formula, but now instead of solving for the arc length, we're going to actually be solving for our angle theta. So I'm going to plug in my values for my variables, make sure it's still on there. All right. So we plug in my values for variables, so I say I have 17.59, and I'm going to say it's equal to, still don't know what theta is because that's what we're solving for. So I have theta over 360 times 2 times pi, and then our radius for this is 14. And so what I can do is I can kind of set up, a multi-step equation where our variable is going to be theta. That's what we're solving for, that angle amount of theta. So how far did that sector turn? So now I can multiply some terms together. So I can do, let's do 2, I'm going to have in parentheses 2 times pi, so second exponent, times 14, and then I have all of that divided by 360. Let's see what we can get here. So we have this is equal to, so I have 17.59 is equal to, and I have some decimals here, so I have 0. Let's have 2443, and we'll say times theta. Again, we're solving for that variable theta, so we can treat it like a wonderful variable because it's unknown. Again, get it set up so that way you can divide by the coefficient. So we're going to divide both sides by that decimal amount. So I'm going to take, let's have 17.59 divided by, and then instead of having to type out that entire amount, what I can do is I can hit second, and then at the very bottom where that negative symbol is, I can say ANS because it will pull that previous answer. So I hit enter to get my angle amount. So I say this is divided by 0.2443. So I can say, hey, that angle amount theta is going to be about 72 degrees. Again, make sure you're saying I set up my formula after I have my labels. I substituted in my values for my variables that I did know, and then I solved for the unknown, which was that angle theta. So make sure you're kind of following those steps to get that variable by itself. So similar idea in the your turn. So now instead of a picture, if you need to draw it out, go ahead and feel free to, but it says given the arc length of 16.76 inches and a radius of 4 inches, what is the angle amount theta of that sector? So same exact setup, have those labels down first, have your formula, and solve for that angle theta. Again, feel free to pause at any point in time, that way you can try it out for yourself. On the back, it has example numero dos. It says find the radius of that circle. And so what does it give us here? Well, it says this. It says, hey, our angle theta is going to be 200 degrees. And then what's that 84 meters squared? Well, I know since it has that exponent of the power 2, I know that's going to be our area. So it actually gives us the area for this one. And so what do I have to do? Well, I have to use the items that I have and plug them into a formula that I can use. So I can say, all right, let's have our area A. It's going to be our angle theta over 360. And we have times pi times the radius squared. And that's actually what we're going to be solving for, because we're looking for that radius. So we're going to have to find what that is going to be. So you can make sure you can substitute in your values for your variables. So I have that our area is going to be 84. We actually have the angle amount, so we're going to have 200 over 360 because we're talking about the part of the circle. And then we still have pi and radius squared. Again, we don't know the radius, which is what we're solving for. So you can make sure you can multiply out what you have. And so I have, well, let's do it like this. Let's say in parentheses, I have 200 divided by 360. And I have times pi. So that's going to give me a nice decimal value there. So I can say this is going to be, let's have 84 equals, and then say about 175, and then times radius squared. Again, divide both sides by that coefficient. So I divide both sides by that amount. Again, I like to use that decimal value that's already in there, so I usually just use that second and then ANS button to keep it more accurate. So I'm going to say 84 divided by second and then negative symbol to get that ANS. So it's going to take that whole entire value and to divide it out. So I'm going to say our next line here is going to be 48.13, and we're going to say that's going to be equal to radius squared. So make sure you're saying, again, your answer should not be 48, because what's that last step that we have to do? We're looking for radius, which is not radius squared. So what's the inverse operation when you have something to a power of 2? It would be take the square root of both sides. So I'm going to take the square root of 48.13. I'm going to take the square root of r squared, because that will give us our radius here. So I'm going to say, let's do, all right, second. Again, notice where the square root button is right next to the exponent 2. So I have square root, and I'm going to say second answer to get that previous amount. Hit enter, and I'm going to say it's about, our radius is about 6.94. Make sure you have those units, and so I'm going to say meters. So I'd say my radius for this circle is going to be 6.94 meters. So again, make sure you're seeing those steps as a recap. Have your labels. Make sure you identify what they give you. Use that right formula. So I'm given area, so I need to use the area formula. substitute in those values for your variables, and solve for your unknown. And then lastly, try the your turn number 2. It says given the area of the sector, so it has areas 9.42 kilometers squared, and the angle amount is 30 degrees. It's asking for what is that radius again, to make sure you can set it up similar to how I did in the second example.